Hi, I'm Adolph Oliver, and this is a video clip talking about compound inequalities. Here we are given two inequalities to consider at the same time, and the solution is their combination, which is often convenient to give as a graph. Now, there are two words here that are important, and we'll see or in a moment. These are used a lot in computer science and statistics, and you'll be running into them more. So here's the idea. If they are connected with and, then the solution must satisfy both inequalities at the same time. Let's give you an example here. You might have something like k plus 5 is greater than 1. And then you have the and. Okay? And then we might say k plus 6 is less than negative 1. Well, the and here simply means that the solution, of this problem comes from both of these guys. And what you have to do is first solve both of them for k equals, and then you can turn around and figure out what the combination, the and is. And means it's got to solve this guy and this guy at the same time. We'll see some examples shortly. Now, on the other hand, you can have the word or in here. If they're connected with or, then the solution is a combination of both inequalities. So, for instance, we could have, again, a similar thing here. In fact, let's just put our same guys down here just to rub this in. K plus 5 greater than 1, or k plus 6 less than negative 1. Now, this will be a different solution than we had on the guy up above here, because up above our answers had to satisfy both of these with the and. Remember, we got to do this one and this one. Well, down here with the or, all we have to do is satisfy one of them. So the solution here, on this is both combined. Now here we go. So in other words, we can have solutions coming from this guy or from this guy. Well, again, we'll see examples coming up, but there's one last thing we want to mention here before we go on, and that is the and condition can also be written as what I like to call a three-sided inequality. Might look something like this. Negative 7 less than equal to x minus 2 less than negative 4, let's say. Now, notice this is an inequality here where we have two inequality symbols being used. In effect, what this says is negative 7 has to be less than or equal to x minus 2, and at the same time, x minus 2 has to be less than negative 4. Well, this three-sided inequality is the same thing as an and condition, and we'll see how we can handle these. In effect, we'll solve them just like we did the guy written up here with the regular word and. Here's our first example, and it happens to be an or, which means that the answer can be this first guy or this second guy. If the A solves either one, it's part of the solution. The first thing you need to do is clean these guys up and get them into proper form here. So this minus 1 is going to go over as plus 1. So I have A greater than or equal to 5 plus 1 is 6. Now, of course, we still got our or condition here. And the second guy over here, we have to do the same thing. This plus 5 has to go over as negative 5. So over here I have A has to be less than or equal to 0. 5 minus 5 is 0. Okay, you always want to get these inequalities cleaned up, solve for the variable nice and clean like this. Now, here's the way I like to work with these guys. Okay, I draw 3 lines here, graph lines. Okay, remember one-dimensional here. This is the A's. And what I'm going to do is this. I'm going to put one of the guys on the first line, let's say this guy, the next guy on the second line, and the third line is going to be our solution. Nice way to visualize this. Now, let's look at the boundary points that we have here. this first one's compared to plus 6. The second guy is compared to 0. Well, on these number lines here, we would definitely have 0 over on the left and 6 over here somewhere on the right. So I indicate these 2 boundary lines. Now, the first guy here, we want A greater than or equal to 6. Well, here's 6 right here, the first one. We've got the equal bar, so I put the solid circle, and greater than or equal to 6 means it's going off to the right. Remember, the A is getting larger than 6. We know that because the large side of the V is pointing toward the A. Okay, the second guy here, okay, we're going to put in the middle. A has got to be less than or equal to 0. Okay, so here's our boundary point, and we shade it in solid because we got the equal bar. And notice the A now is getting smaller, so it's going to go this way. Well, okay, since it's the or, it can be this guy or this guy. And so the combined solution here in this problem, we just combine both of these down here. Here it goes. Okay, this is our solution as a graph. Okay, now we can also indicate this in set builder notation, and that's particularly easy because you just go back up and get the inequalities that you have up here. A greater than equal to 6 or A less than equal to 0. And remember, you put the such that line in front. The variable here is A, and you put the curly brackets around it, which means this is the set of answers. And so what we're done here is we've given the rule. This is all the A's such that A is greater than 6 or A is less than or equal to 0. So you can do it in set builder notation. Okay, here we go. Or you can do it as a graph solution. In fact, you should be able to handle either one of these. Okay, let's look at a case now where we don't have or, but we've got the and situation. Once again, the first thing you need to do is clean these guys up. I've got 6 times P is less than equal to 30, so I've got to divide both sides by 6, and that gives me here P is less than equal to 5. Then we have the and condition. Okay, over here we need to do some cleanup also, so I'm going to divide both sides by 5, and we end up with P, okay, is going to be greater than, looks like it's -1. Okay, so let's double check this. P is less than equal to, this reduces to 5, and P is greater than -1. Okay, once again, to give the solution on here, I'm going to draw my 3 graph lines here. Here they go. 1, 2, 3 of them. And these are my boundary points, 5 and -1. Now, -1 will be over on the left here someplace. So let's say this is -1, and 5 is going to be over here on the right someplace. So let's say this is 5. Now, here we go. Once again, I'll take one of these guys and put them on the first graph, the other guy on the second one, and then our solution will be down here on the third guy when we finish him up. So, here we go. The first one, P has got to be less than or equal to 5. Well, the boundary is 5. We got the equal bar, so here we are. The P is getting smaller, so that means the answer is going to the left. Okay, that's just grafting the first one. The second guy, P greater than or equal to -1. Notice no equal bar here, so the -1 will have to be an open circle, but the P is getting larger, so it is going this way. Well, okay, remember, these are our solutions here in both these. When we have the and means it has to solve both of these. Now, folks often talk about and being the overlap where these two guys do overlap. And notice there's an area here where the values occur in both. So here we are. On the left, we've got the open circle. On the right, we've got the closed circle. And simply everybody in between. Now, one of the things about this is you can write this as one of these three-sided inequalities. The left boundary, -1, has got to be smaller than the P, and the right boundary, notice it's solid, so we have to put the less than or equal 5. So you could say P has to be greater than -1 and at the same time less than or equal to 5. Well, now, of course, to make set builder out of this, all you do is turn around and rewrite this inequality, put the such that line, our variables P, and put the curly brackets. So this would simply say the set of answers here is the values of P such that P follows this inequality right here. So we could graph the answer, we can write it as set builder. Well, we can also be given the problem as a three-sided inequality to begin with. And remember, this is just a more compact way of writing one of the and conditions. But here's the idea. To be able to get this correct, you have to get in the middle here just a variable all by itself. So if there's any cleaning up, any adding, subtracting, multiplying, or dividing needs to be done to do that, that's the first thing you do here. Well, notice this is x divided by 3. How do we get rid of divided by 3? We multiply by 3. Okay, now of course, since this thing is three-sided, we got to multiply all the sides by 3. So I might indicate that up above here like this. Okay, 3, 3, and 3. And of course, the guy in the middle here, 3 divided by the 3 up here, you're basically just reducing. You get the x by itself. Now remember, you've got to, of course, combine these 3's on either side. So this becomes -3 less than x less than 2 times 3, which is 6. Now let's double check that. What we did is we multiplied everybody by 3. Now notice this was +3, so we didn't have to flip the inequalities. If you were multiplying by something that was negative, you'd have to flip the inequalities. Anyway, here we go. The 3's cancel in the middle, so we just get the plain x like we wanted. -3 on the left, +6 on the right. Okay, well now we can go ahead and graft up the final solution on this. And in effect here, we've got it done for us right here, because -3 is going to be somewhere over on the left here, +6 somewhere over on the right. The x's are going to be everybody in between, and notice there's no equal bars, so both of these would have open circles, and we just shade the area in between. That's how you'd make a graph out of it. The x's would be any values that were greater than -3, not equal to -3, but anything greater, and at the same time got to be less than 6. Can't be 6, but anything less. Well, that was quick. And of course, the other nice thing here is to make set builder, we just go ahead and grab our inequality, our three-sided here, -3 less than x less than 6, put our such that bar, the variable is x, and put the curly brackets around it. There we go. So it's often much easier to work with one of these guys. Well, here's another one down here that's three-sided, but it's going to take a little bit more cleaning up. Okay, so here we notice, okay, the x is in the middle here. We've got to get the x all by itself. So the first thing you always do is move anything by adding and subtracting. So I got to get rid of this -5. So in effect, I'm going to add +5 to all three of the sides here. Well, when I do that in the middle, +5 and -5 give me 0. That's what I want to start cleaning it up. I still have more work to do, but I've made some improvements here. Now, on the left, -75 plus 5 gives me -70. On the right over here, -12 plus 5 gives me -7. Now let's double check this again. 5 added here gave me 7x. 5 being added here gave me -7. 5 being added here gave me -70. Alright, looks good. Now, we got to get rid of the 7 times, so I'm going to divide everybody by 7. Okay, well, here we go. -70 divided by 7 is -10. We got our less than equal sign. The 7's cancel out here. There's the x by itself. That was our goal. And -7 divided by 7, -1. Let's double check this. -70 divided by 7, -10. -7 divided by 7, -1. Well, okay, again, now that you have this cleaned up, it's very easy to graph the solution. -10 will be over here someplace. -1 over to the right of that someplace. Notice that the boundaries here, the -10 and -1, the inequalities both have the equal bar, so that means we're going to make solid circles on both of these. And now, of course, what you do is just turn around and connect everybody up in between. There we go. Okay, so what do we end up with here? If we want to write this as a set builder notation, just rewrite the inequality. Okay, here we go. Put the such that line in front. The variable is x, and the curly brackets around it. Okay, so there's a way that we can write this. Well, here's another problem, not written as a three-sided, written with the regular word and. So we got to solve both of these guys at the same time, and both of them are going to take some cleaning up here. So let's do this. Remember, we always want to solve for the p on the left, and then whatever the inequality and the rest of the number is on the right. Okay, this first guy, -12, has to jump over as +12. So let's see, we end up with 10p greater than equal to, and 58 plus 12, 60, looks like it'd be 70, I think, huh? Okay, so 58 plus 12, 70. Now, to get the p all by itself, divide both sides by 10. And the 10's cancel out, so I get p greater than equal to 70 divided by 10 is just 7. Okay, there's the left side cleaned up. Now, of course, remember, we have the and in between them here. Okay, the right side over here. Here we go. I want to take the 11 and jump it over to the right. So this is plus 11, goes over as negative 11. Okay, so I'm going to end up with negative 6p is greater than, let's see what we have there. Both negative, so it looks like negative 48. Huh? Negative 37, 11, 48. Yeah, looks good. Now, here we go again. We're going to divide both sides by negative 6 because we want to get rid of this negative 6 in front of the p. Now, remember something about inequalities. If you multiply or divide by something negative, you've got to flip the inequality. So there it is. I do that real quick before I forget. Negative 6's now cancel out. So I get p less than equal to, the two minuses are going to give me a plus. 48 divided by 6 is 8. Huh? 6 times 8 is 48. Okay, now, here's the interesting thing on this one here. Okay, we've got the p greater than equal to 7 and the p less than equal to 8. Well, once again, what I'm going to do is draw the 3, and not doing a very good job making nice even lines here, but here are the boundaries. Somewhere here is 7. Somewhere over to the right, 8. Always make sure you get these guys in numeric order. Okay, I'm going to put the first guy on the top line here, and we want p greater than equal to 7. So I make a solid circle because I got the equal bar and the p is larger, so it's heading off to the right. Okay, the second guy here. Okay, boundary is 8, but notice no equal bar, so that means I make an open circle, and the p is getting smaller. It's going this way. So there it goes. Okay, well, the solution down here, okay, and the last one, since it's and, it's going to be the overlap. It's got to solve this and this at the same time. So the solutions that are over, notice the 7 occurs on both of them, so I make a solid circle here. Over here, however, the 8 only occurs on one and not the other, so since it's not on both, we still have to use the open circle, indicating it's not part of the solution. But everybody in between, okay, is good. So, as an inequality, I could write this as 7 less than equal to, what letter are we using? P, less than 8. Okay, write it as one of these three-sided guys, and put the set line, and the variable p, and the curly brackets, and there it goes as set builder notation. Okay, let's look at one last example, and it's an OR guy here that needs a little bit more cleaning up. And so that's the first thing we're going to do, as always. Okay, on the left side here, the negative 10 needs to go over as positive 10. Okay, so I have negative 8n, okay, is greater than or equal to, and let's see, negative 82 plus 10 looks like negative 72. Well, okay, I got to get the n all by itself, so that means I got to divide by negative 8. So here we go, divide both sides by negative 8. Now once again, remember, if you multiply or divide an inequality by a negative value and we're dividing by something negative, you got to flip the inequality. So here it is. Okay, the negative 8's cancel out, so I have n less than equal to. The two minuses give me a plus. Let's see, I think 8 goes into 72 9 times, huh? 8 times 9 is 72, so n less than equal to 9. Notice it's positive. The two minuses give me a positive. Okay, then we have the or. And now we got to clean up the guy on the right side. Okay, the plus 1 goes over as negative 1. So I end up with negative 5n, okay, is less than, and this looks like negative 55. Okay, well, here we go again. To get the n all by itself, got to divide both sides by negative 5. Well, once again, we've done something that causes us to flip the inequality, so be sure you remember to do that. Whenever you multiply or divide an inequality by some negative value, you've got to flip the inequality. Okay, the negative 5's cancel out, we get an n. 2 minuses give me a plus. 5 goes into 55 11 times. Okay, so here we are. Now, once again, as always, I'm going to make my 3 graph lines. Now, even if they just want the answer in set builder notation, it's usually wise to do the graph business here so you can visualize what's going on, and it greatly increases your chances of getting the problem correct. Again, the first guy will go on top, second guy will go in the middle. The boundaries are 9 and 11. 9 occurs, let's say, over here, and 11 will be somewhere over to the right, 11 being larger, greater than 9. Okay, n is less than or equal to 9. Well, we've got the solid circle since it's less than or equal to, and the n is getting smaller, so there's our value. Okay, over here, the boundary is 11 and no equal bar, so we have the open circle, n is getting larger, so here it goes. Okay, well, remember, since this is an or, the solution can be either this guy or this guy. All it has to do is satisfy one and it's good. So we combine these. So the solution then is the n's going from 9 and lower, or you can have the n's going from anything that's greater than 11 and higher. But of course, remember, 11's not allowed. So there's our solution. Now, to do this in set builder notation, you basically just have to write out the ors up here that we have. So n less than equal to 9, okay, or n greater than 11. Put your set line, the variable n in front, and the curly brackets around. And that's how you write it in set builder notation.